So what we always like to do, while we've got people here, while we've got people who are involved in developing the standard, developing the implementations, and using SYCL and OpenCL, we always like to then put some of them on a panel and give everyone else a chance to ask some questions. So these can be serious questions, these can be challenging questions, they could be silly questions, we really don't mind. So while we've got these people here, and we'll get everyone to reintroduce themselves because we are recording, and you might be listening to this sort of afterwards and not have seen people already say who they are. So we'll get you all to introduce yourselves in a moment, but we'll just wait for Michael to come back. But start thinking about any questions you might have that you'd like to put to our panelists. Thank you, Michael. We've got a microphone for you to share. So if we start off with, if we get you all just to say who you are and what your involvement is with SYCL or OpenCL. So what, in other words, why you think we put you on the panel. Okay. Thank you.
I'm Nevin Lieber. I work at Argonne National Laboratory in Illinois. I work on C++, Kronos, SYCL committee, the WG21 committee for C++, as well as I'm vice chair of the US delegation. And I work on COCOS as part of my day job and Aurora.
My name is Axel Alpay. I work for Heidelberg University and I lead the HipSYCL implementation of SYCL. And like Nevin, I'm part of the SYCL working group, and together with Michael.
I am Leonidas Kosmiris. I am senior researcher at the Barcelona Supercomputing Center and member of the faculty of the Polytechnic University of Catalonia. My research is focused on safety critical, of the use of GPUs in safety critical contexts. I have served in Kronos advisory panel for Vulkan Safety Critical and in the exploratory group of SYCLC, and we will join also as in the SYCL Safety Critical.
I don't think you need me to.
Oh, we do because we're being recorded. Oh. People might be listening afterwards and won't have seen your previous one. So if you don't mind, Michael, just say again, yeah.
So I'm involved in all things SYCL, I think. SYCL chair, and I'm deeply interested in SYCL SC. I'm the AutoSolve chair, and I'm also involved in C++, like Nevin is. Been there for about 20, 25 years. And now I'm also involved with safety critical, with machine learning, and investigating how to make the RISC-V data center work with accelerators. What's your name? Oh, my name's Michael Wong, sorry. Sorry.
So people listening to the podcast in their cars driving around in like 6 months' time, you see. We'll have that there. Very good. So thank you very much, and thank you, panelists, for agreeing to be here. So I actually have a question to get us started. It's something that a few people have already kind of mentioned to me, and it's been great. We've been seeing some very interesting results so far. People have been presenting on comparing SYCL performance to sort of other approaches. And at the moment, in many cases, SYCL performance is still behind sort of CUDA or OpenCL. And so be very interested in your thoughts of why you think that is, and if it's going to be possible to close that gap. Can we get SYCL to catch up with the other approaches? So who would like to take that first?
I can start.
Yeah, please.
So actually, there are two types of answering this question. First of all, I would say that for a standard that tries to be hardware agnostic, it would be normal to be less performant than optimized code for given architecture. The other part of the answer is that, as we have seen in many talks today and also including ours, there are specific cases that SYCL performance can be even beating optimized libraries for vendors. So yeah, it's not that far behind, in my opinion.
So I agree that SYCL is not necessarily slower than CUDA or something else. I mean, if it is, then it might just be because the CUDA version of the code has been around for longer and the SYCL version of the code has just been quickly typed together. And of course, if you just quickly type something together and maybe just run it quickly to see if it works, then it's maybe not as efficient as something that has been optimized for years and years. But that's just due to things being new. Another thing is default. So ultimately, many SYCL implementations use the same compiler backends, the same LLVM backends that vendor compilers also use. So there's really no reason why things should be any slower. But for example, some compiler flags might be set differently by default, and drilling down to all these details and really making fair comparisons can be quite hard, and oftentimes comparisons are not fair.
Yeah, I mean, for us, like, as part of Aurora, SYCL is a fundamental technology, but we needed it developed. Intel didn't have this for us, and now we do. And first we needed, you know, you can make things correct and then fast. You know, it's hard to make things fast and then correct. So now that we have, you know, a good SYCL implementation, yeah, we expect it to getting a lot more optimized.
Right. So it's a great question. Like, you know, how can we catch up? You know, and these others have had a long lead time, a longer lead time, and they've been involved in many more, exposed to many more ecosystems, domains. We need to start somewhere. So we have gained a foothold, a very strong foothold in high performance computing. We have a reasonable placement presence in desktops and some embedded computings. And then obviously we're now also entering automotive in safety. But we also need to be entering a lot more domains, but that effectively takes time. Whether we can you know, match the, you know, the prodigious output of something like CUDA, basically demands that we have to have essentially a larger audience over time. It will take time. I think we will. I think we can achieve that, but it's just something that needs the momentum now. Having one API on our side helps, and they're already gathering momentum with more people joining. And I think as that happens, a lot more people will start using SYCL and its associated ecosystem. And I think that is why I think the outcome will be the way we're thinking of. Yeah.
Okay, so I think I'd sort of summarize response as it's going to take a bit more time. It's still quite new, it's quite immature, but other than that, there's no particular problem. No one sort of highlighted anything in particular. So what does the audience think of that? Do you agree with that? Do you not agree? You think it's all fine, just need a bit more time?
I mean, are there abstractions you think we can't make faster? Let us know. I mean, we're on the committee. We can, change that if we have to. But yeah, is there anything, that comes to mind?
Yeah.
I think for large parts, like consumer electronics or mobile devices have proved to be accelerators for most of the technologies around them. What do you guys feel about foray of SYCL into more of a consumer device applications where there are many different kind of dedicated processors, GPUs, and probably not that much foray from CUDA, essentially?
If you'd like to take that one.
Consumer devices. Consumer devices, you're saying, yeah. I don't see why not. I mean, I think we've been trying to do that with exposing ourselves to different conferences, not just HPC, but at CPPCon, definitely more consumer device focused. And we've been trying to do more and more at CPPCon, but this disruption has disrupted the whole world. Another thing I guess I also want to say is, our catch-up technique is a little different, right? I mean, a lot of these other, well, not OpenCL, but certainly CUDA is a proprietary, a closed, and that works well for them, and that's how they want it anyway. Maybe they're going to open it. I don't know. There's been threats that they might open it, but at the end of the day, I don't know if that will really work. But I think the fact that we're agnostic to hardware, we're capable of porting to a lot of different platforms, ultimately will give us a lot more momentum once a critical mass appear.
Also, consumer devices are a different kind of trade-off. Like my cell phone and my watch, right? They spend as much time as possible trying to shut themselves off to preserve my battery to keep it, going as long as possible, which is a different trade-off than, say, for HPC, where we need, to use as much of our processors as we can. So we would have to, take more of that into account, and I think that's hard. And plus, like companies like Apple don't typically let outside technologies in anymore.
Yeah, I would also say that for consumer devices, many of them support already OpenCL, so there is a way to use them with SYCL.
You know, when I was doing OpenMP, I've actually always thought about this. Why does the world divide into languages for HPC computing and then languages for the consumer world? You know, the people who plays games and the watchers. One of my dreams certainly was to find a language that can unify those. And I don't know if SYCL is it, but it certainly has more promise than most of the other ones.
I think one thing to figure out for that use case is the deployment model that we would follow in a multi-backend SYCL implementation world. It's fairly easy if you can assume that all your target devices will be able to ingest your IR and then feed it into OpenCL. Then you just need to rely on the OpenCL ICD loader and things will magically work. But what happens if on some device you need to dispatch to CUDA or to some other API? What part of your runtime stack will be provided by the platform and what part of the stack will come with your application and with SYCL? And I think these are questions that we need to figure out in order to penetrate that market better.
That was a great question, thank you. Very good. Yeah, another question at the back.
This is kind of related to what we've been talking about, but I guess one thing that, I think would really, push more adoption of SYCL is to increase the amount of vendor support. So obviously Intel are very, very much behind SYCL. But do you think there's any scope for kind of increasing the official support from other vendors?
Okay, so I've always said that the way it works is that the customers has to ask their vendors for it. The vendors, probably the only reason, I don't know totally, but the main reason I think Intel went into it is because Argonne, somebody at DOE asked for it. As vendors, and I used to work at IBM, and I guess now I'm kind of working at Intel now. We don't actually have that much power at deciding what paradigms to adopt. Actually, we can initiate some, but it's actually the customers that can make us do things. And really, that makes sense because it's the marketplace that decides. Yeah, go ahead. Chris, sorry.
I was just going to question you, actually. Is that true? I'm not aware of the history. Is NVIDIA's proposal not that they have a complete solution, that they have GPUs with a programming paradigm and they offer it as a whole? Were they really, did somebody ask them for it or did they come up with it?
I'll answer that right away, and it's a good question. I'm glad you asked it. The difference is that they were there first, or kind of first, and that's a powerful thing in our industry. In our industry, you have to either be better or you have to be there first. And if once you're there first, you gain a tremendous stronghold and you become the 800-pound gorilla. That's why we had WordPerfect. That's why Yeah.
So one thing to add to this discussion is I would be careful to oversell the impact of vendor support. Because I think one mistake that OpenCL, for example, did was rely that vendors would chip in and rely that vendors would provide OpenCL implementations. And that, I think, is one of the reasons why ultimately it didn't work out that well. In SYCL, we now have the situation that we can implement it on top of whatever the vendor likes. And I think this is a huge advantage. And I think we see from the performance and from the reliability of today's SYCL implementations already that we can get much of the same things that you would expect from a vendor-supported implementation, right? Bugs get fixed, performance is good, features are coming, right? So from a technical point of view, ultimately many of SYCL implementations go through the exact same compiler backends, LLVM backends that vendor compilers use too. So there's no real technical reason to hope that vendors will make anything particularly better. What is important, though, I would say, is that there is some stability in terms of the resources that are poured into SYCL. So that means manpower to develop implementations and overall all resources and ultimately also money. But where that comes from, I think, is not that important.
So that's, I'll just comment, I think that's a very interesting, the observation is actually the community is doing it itself more now, and that's more feasible than it has been before. So we're less reliant on whether the vendors are going to do it. That's a very, if that's how things have evolved. That's very interesting.
Yeah, actually, I would like to second what they just said, that the power of a programming language or a programming API, actually it's their users. So the more users we have, the more support we are going to get. And it was very promising what you showed this morning, that I mean, people are using more and more SYCL, so this is really promising.
I was just going to ask, because somebody made the observation that because of, and I don't know who, because of the way SYCL is implemented, you only really need one because it then sits on top of the vendor's implementation. And so is there a danger then that that we're actually fragmenting our own market by there being multiple SYCLs? I mean, if I come along now, I don't know which SYCL to use, right? I mean, there's a list of 10 on the board. Is there? Difficult question, because everyone wants theirs, but is there a danger that we now have, you know, multiple standards?
And I don't know that we have multiple standards. I mean, we have multiple implementations, but you know, C++ is kind of in the same boat, right? You know, Python, like there's basically one implementation, right? There's a few, but you know, Rust, there may be more. Go one, you know, C++ has a specification and different standards, and you know, but we're yeah, a lot have just gone. I mean, there's, you know, the big ones are GCC and Clang, and you know, EDG are like the three biggies these days. Is that fragmenting? I mean, because if it gets down to one vendor, then it's not really a specification, right? The implementation is the specification. And you know, as a customer, right, over here of all this stuff, right, you know, we don't want vendor lock-in, because you know, new supercomputer comes at a different lab, or our lab, it could be based on a different chipset from a different vendor, and we want our codes to still just work. And if right now, yes, yes. Otherwise, it's not independent. It's basically, then there's only one. You're saying if there's only one implementer. Only one. Yes. Well, Argonne doesn't want to be in the compiler business. We really don't. Right? We want vendors to give us tools to work on their hardware, and then we can do things on top of that. Yes. You might still need someone to do the back-end coding of that.
So actually, the power of a standard is to have a solution that can have multiple implementations that conform to the standard, and then the end user will select whatever fits better their needs. Someone might need something that is open source, royalty free, and no need to pay any fee. Another industry, like a safety critical industry, will need another product that will come with a qualification package. So probably it cannot be satisfied with an open source tool that doesn't follow a process like what Eric was describing before. So we really need different implementations. And also, if we have only a single implementation and that stops getting support, then it dies.
I mean, I would even go one step further. What is even the point of a specification if ultimately you're only going to have one implementation anyway? Then you could just stop wasting effort into writing everything down and just say, okay, it's faster, we can move much faster, be more agile if we just say that. Well, I mean, realistically, there are a lot of more research, experimental SYCL implementations. The SYCL implementations that you would probably use for a production code, I think there's much less to choose from. And the fact that you can choose from the SYCL implementations and you cannot choose from your CUDA, I think is a value in itself, because it allows you sometimes to find bugs in your code, or it allows you to experiment with maybe the performance of your code that might be different on different implementations. And also it allows different implementations to develop different characteristics, focus on different use cases, or even allows the ecosystem to experiment and broaden into more directions, because more people can experiment on more fronts, different things. So I don't see how it subtracts anything. I only see how it adds.
So I think I see Chris is, well, you're kind of probably being a devil's advocate just to check this, and it's good. I don't think CUDA's success is because it has only one compiling system. I mean, CUDA's success, I'm not going to try to explain it because everybody's going to have different opinion, but certainly largely it was the first, as I said before, and they had a great strategy of spreading it to a large number of ecosystems. And then at some point, there was a bit of luck involved and timing involved where ML came along and kickstarted to an even higher gear. I want to address the question of the multiple compiler, because I've had a lot of thoughts about that. I don't think it's fragmentation. I think it's only fragmentation when you have many things doing, when you have many things doing the same things. I don't think the fact that we have multiple compilers, I think they're doing different things. They're serving different groups and different communities. In fact, in my career, I've watched compilers whittle down from what used to be about 6 or 7 C++ front ends now to largely only about 3. And I think that my conclusion now is that that's kind of a bad thing. There's now less diversities. It's harder to check each other. You really have about 2 or 3 opinions, and they dominate the committee sometimes in terms of who's right and who's wrong whenever there's an ambiguous issue. And I don't like that, actually. And I've had this discussion before. People say, why can't we just have one C++ compiler? Because then you get absolute portability. Yes, but then you also get a lot of other bad things, which I'm hoping other people will talk about.
And there are libraries that only have one implementation. Like MDSpan, like the reference implementation comes out of the Cocos group, and that's so far the one, CUDA adopted it. It's the one everybody's using. And yeah, I don't think that's good either, because we don't know that there may be bugs in the specification, and people start getting very dependent on the implementation. And it means we can't change it, we can't make it better if we find problems.
So before we go on to the next thing, I just want to, one thing that someone said that it's worth everyone thinking about. One thing you can all do is when you talk to vendors, if you want SYCL or you want OpenCL, you want something you don't get from them yet, ask for it. And they'll probably say no, and they'll probably say, oh, no one else is asking for it. I get that from NVIDIA all the time. They say, well, no one else ever asked us for SYCL or anything like that. And you know that they have. But it does get logged somewhere, and it does make a difference. So it is worth asking. So that's something everyone can do. Yes, sir, at the front.
So I want to touch back on the first question about performance. So I don't think it's the only point of view we should have, especially from a user adoption point of view. What I mean is that, yeah, maybe now at this moment SYCL is a bit worse than, for example, CUDA implementation performance-wise. But a user sometimes is not only concerned about performance, sometimes he's also concerned about costs. So it may be less performant, but it might be cheaper to run because it allows you to free market. You're not anymore locked in on a specific hardware. And basically, I want to know more about like allowing customer to basically be on the free market to choose on which hardware to run. Is it actually maybe the biggest benefit of SYCL, I think? Because it will allow actually to lower prices because users are not locked in anymore on a specific hardware? Or maybe reduce the advantage of being the first one in a specific field. So what is your thought about it?
So I can try to answer that question from the safety critical market point of view. as I mentioned, we have been working in this GPU for Space project. We have been evaluating different programming models from different architectures. And actually in these domains, they don't care only about performance. It's exactly what you said, it's cost. Because mainly the development cost. You put an engineer to develop some code. It doesn't matter if they optimize the code to run at the peak. If they get enough performance with low effort, that would be enough for the use case. And that can make a huge difference in lowering the cost in the development, in shortening schedules, specifically in the space market. You have really short windows to launch. If you miss that deadline, maybe you have to wait 10 years more. So, yeah, it's really relevant.
Anyone else on the panel want to comment on that?
I actually didn't remember the question.
Oh, so the question was, what are the
Yeah,
actual main benefits of SYCL? Is it the fact that is it more attractive that you're not vendor locked
Well,
in anymore?
I mean, we've had like three, right? We've had performance, we've had power, and we've had time to market, right?
Yeah.
Those are all different costs, and people have HPC, right? Performance matters probably more to us than the other two. But my cell phone, yeah, my battery needs to last on my flight home. And time to market, yeah, if you miss the window, you're out of luck. I mean, and that's just hugely bad. So.
Yeah,
we'd like to appeal to, of course, everybody wants to appeal to all these markets, and I think we have a good shot at it.
Yeah, we did see several results reported saying actually it was much easier to write the SYCL code than the other version, so that sounded very promising.
I can try to say, for example, in the past we used to have the cell processor, and it was notoriously difficult to program. So that was another example, a very successful hardware architecture that failed because there was not, at that moment, a programming model that could make the use of this hardware efficient. And now we have a lot of opportunities inside Kronos APIs.
I used to work on the cell processor.
Sorry for that.
Very good. A question at the front. Thanks, Alexander. Rod.
Hi there. There were quite significant changes between SYCL 1.2.1 and SYCL 2020. And I think for people who are developing SYCL at that point, it's probably caused quite a lot of pain as new features have been implemented and other features haven't been implemented. How does the working group propose avoiding similar sort of big breaking changes as you move forward to the next version of SYCL as more people are using it?
Mm-hmm. Great question.
Yeah, I mean, as time goes on and we get a bigger user base, it gets harder to make those breaking changes. But we need to make progress, right? That's one of the hardest things. Like on the C++ committee, it's we do occasionally break things, but the bar is really high, and so we have abstractions we'd like to get rid of that we just can't because we know there's 20-year-old code dependent on it. SYCL, at least to 2020, right, was in early days. Yes, it was painful to break things, but we could still do it without infecting too many people. And personally, I wish we could get this more as a conversation between the committee and users because we want to make progress, right? We don't, we're not looking to break people, right? It's looking to make progress so we can have things that are supportable APIs and are better APIs. And it's hard. It's a really hard thing to do.
So, I'm going to use this chance. Thank you for asking that question to launch into my. So yeah, some of the things I would argue that it was the right moment to make that change. But the biggest thing we did was certainly to detach from OpenCL and enable ourselves to be able to support on many different kinds of backends. I actually envision that change to continue, and I want more of it to continue because I think there's still some remaining attachments to OpenCL that we need to continue to separate in order for us to enable to support even more kinds of backends. Right now, if there's some there could be exotic backends out there that if we try to attach it, it would be difficult there would still be some difficulties that remains, and we need to be able to completely reach the point where we move more towards more C++ like, okay, and lesser of OpenCL.
So when you say breaking changes, I would actually say that transitioning to SYCL 2020, we've had fairly little really breaking changes. I think for the most part, what we did was generalizing things and adding new features. I think the biggest pain that came from SYCL 2020 was not that we broke the APIs in the specification. It was for the most part that it was a huge pile of features. So basically, we've dumped everything that came up in our minds for the last couple of years into one specification. And that then means that there's a huge cost to update the CTS, which also why it took comparatively long to get the CTS up to speed. And it's also a huge cost for the implementations to catch up. And still we have the situation that implementations are not up to date with the latest SYCL 2020 specification. And that also means that there are difficulties porting code from one SYCL implementation to the others because the feature support levels are different and so on. And I think one thing to address all of that and also to ensure that there's more implementation experience before we actually standardize things would maybe to consider having more frequent but smaller releases of the specification so that we can, for example, have one specification update that focuses on one feature. It's fairly straightforward then to update the CTS. It's fairly likely then that all SYCL implementations would probably have tried implementing that feature or at least thought about it. And I think we could, in that way, avoid some of the trouble that we had with SYCL 2020.
And a lot more clarification over SYCL 121 in terms of wording. And without the clarification, vendors just, people get dependent on things because they read something, they kind of think they know how it works, they tried it out in their compiler, and we finally clarify it. We unfortunately break, we break people by doing that. We do feel bad. And we don't want to do it, but.
Great questions. A couple more.
So my question is, if you look at the history of OpenCL, right? OpenCL 1.2 is actually was the most popular one before 3, and when it goes to OpenCL 2, and it's becoming more fragmented because of some really advanced features that not everybody can support. So my question is my first question is, how SYCL can avoid this kind of mistakes that OpenCL had before. You mentioned that SYCL is getting a lot of cool features, but I think from some mobile vendors, right? So it's actually becoming a burden to adopt. That's my first question. And my second is how SYCL working group improve this library support, like QCN or other libraries that make CUDA successful. I think one major reason that CUDA is popular is they really have this good support of many libraries that make it work a lot easier for different areas. So
I'll start with so for SYCL 2020 we use C++ 17 as a base, and this gives us features like deduction guides, which make SYCL so much easier to use because you're not having to specify a bunch of template parameters that, quite frankly, we don't really care about. And so things like that will hopefully get it to be more popular because that's C++ is also giving features that we can take advantage of to make things better.
So, yes, SYCL 2020 definitely made it a lot less verbose. It still can be better, I think. Along with the fact that you have now CTAD and the deduction guides, I think it's probably increased the compile time. It might, because there's a lot more templates being processed, but I'm hoping that modules and concepts will fix that back. And that's what we need to do with SYCL. It needs to keep moving with C++, adopting, modularize and conceptify as we move forward to the next stage. Can you say your second question again? Sorry. The libraries.
Library,
Yeah,
yes.
libraries. I totally agree. We don't have nearly enough libraries. C++ doesn't have enough libraries, so we don't have enough libraries. But for that needs contribution from a critical mass of people. It can't be just done by, you know, a few of us. Most of us are involved in the day-to-day, you know, work of trying to refine SYCL and add new features and things like that. And I think that's basically that's another thing that just takes momentum to build up. But we definitely need, totally agree, we definitely need a lot more libraries. And your first question was? Okay. Okay, that's a good one too. I think fragmentation happens in languages when you put features in there that not everybody implements. I have seen this in C99, where they put in like variable length array. Yeah, and nobody implements it, and then they have to retract it and pull it, and then this is absolute death for programming languages. We have to avoid that at all costs, and you know, as a member of the SYCL group with these guys here, we're going to do everything we can to basically bring everyone along together. That's really, I think, the only secret formula. It's not even a secret. You can't put things in there that really are going to just benefit one or a few. Things like that, because what happens is they don't get implemented and the language just goes dud. And that's kind of what's going on there, right? I mean, not everyone implemented that OpenCL. And now you got to retract things and you got to do all kinds of, I don't know.
And I'd like to add on top of that, I mean, in SYCL, the idea is to be hardware agnostic and relying on other Kronos APIs as backends. So we avoid that risk, in a sense, because by relying on APIs that already have universal support by different vendors, we will avoid this risk.
I mean, I think it's still fair to point out that some party might argue that, well, in order to be competitive with some other API, we need to have feature X, and this is needed on this hardware to obtain performance. And I think this is really a difficult trade-off in some circumstances. And what we can, however, do in SYCL is that we can always say that, well, we have this multi-backend architecture. So if you really want to develop something that's only really good for one particular backend or architecture, you can always do SYCL 2020 backend interoperability and do whatever the backend can support. But then you're doing it fully conscious that this is something that's only for this particular backend because you want to optimize for one particular thing or use case or whatever.
So part of the SYCL 1.2.1 to SYCL 2020 pain was, in my experience, that there have been many vendor extensions beforehand that kind of implemented this stuff, but kind of had different APIs and so that kind of thing. There's other APIs like Vulkan where the extensions are also more or less in the standard. Is that something that like you need more of a process in the SYCL standard, that you have extensions that are already like discussed by multiple vendors, or is it something that, well, just go on and do whatever you want in your SYCL implementation?
Yes. So I'd really like to see a forum, ideally outside of Kronos, where implementers get together and just openly discuss their ideas for extensions instead of everybody, you know, first doing their extensions for their implementation by themselves and then only later finding out that, oh, well, these other guys, they did something similar to solve a similar problem, but they have different APIs, and now we have like two competing APIs that we need to reconcile somehow. I think there needs to be a better process, and we need to talk more to each other among the implementers.
Oops. In the middle back there.
Since it's OpenCL and SYCL panel, do you believe there is any reason to choose OpenCL over SYCL for new projects, or is OpenCL more or less a legacy technology, at least for user applications?
I mean, there are obvious reasons when you would want to choose OpenCL. I mean, if you're in the business of wanting to have a separate source model where you can maybe auto-generate source code at runtime, which is still something that some frameworks do and rely on, this is currently much more easy to do with OpenCL, which is kind of built on top of this idea, than it is with SYCL, where you kind of need to shoehorn it into the workflow because it's not there yet. So this is something that I would say OpenCL is more suited for.
Yeah, and on the other side, if you want to have I mean, something that takes less effort to develop, go to a high-level programming model, which is SYCL, and you can save a lot of time, a lot of bugs.
Hi. We have been talking about the good stuff of having different implementers, maybe some backed by big companies, other backed by small universities. And we're also talking about adding new stuff to the language while keeping the old stuff to be retrocompatible, like do not break API or API compatibility. How do you think this might affect having this bunch of implementers? And especially, well, this is a question maybe for Axel. Do you think this might affect like having unlimited manpower, like having to support new features at the same time keeping the old in your implementation?
Sure. I mean, there are cases where we have features in SYCL 1.1 that are really, really difficult to implement, such as hierarchical parallelism, where we at the same time say that, well, I mean, we currently discourage using it in the SYCL 2020 spec because we're redesigning the feature. So, but you still have to implement it, which is a huge effort. And I think maybe we should really make sure that SYCL remains implementable with an effort that is acceptable for someone who is maybe not Intel. In order to have good coverage of features across implementations, because otherwise there's also a way that you can create fragmentation of features. And I think that one way to do this is, as I said, focus on smaller changes in the spec rather than doing the really big things. And again, like talk to each other.
This is actually also a problem in C++. And only recently, I think we're beginning to become more aware of it, where people are taking account of implementability into a factor when a feature is to be accepted. I actually haven't seen this in C++ for about 10 or 15 years, but I think it's important to always check the implementers and see if a few of them are vetoing something, because that's telling you something that's significant.
One thing I'd like to add is, I think we should maybe consider in SYCL learning from C++, where, for example, the compiler developers generally don't have to worry about the implementation of the C++ standard library, because ultimately the compiler can always use libstd C++ STL, for example. And I think it would be a huge simplification if we could say, for example, the SYCL compiler developers can focus on the core features that need to be supported in order to be able to offload some code. And then, you know, the whole template library that SYCL offers, maybe that can be shared in some way.
Yeah, you know, on that point, you know, we don't even know that we can use things in the standard that necessarily can make it onto the device. Like, can I use standard plus? Probably, but there's no actual guarantees for that. And yeah, if we can get those guarantees, we can take a lot of those kind of things out of the SYCL spec and just use the standard one and focus more on the things that we're contributing that are not in C++.
Sure, but I mean, even within the SYCL headers that we have today, right, we could probably share a lot of stuff. Why should everybody implement SYCL ID or SYCL range, or even some of the newer features like SYCL M-array, which are probably going to look very, very similar for every implementation? I think there's potential to join forces there.
This might have been answered implicitly already, but I'd be interested to hear from each of you. What do you think the doomsday potential for SYCL would be? Like, what's the most biggest threat, do you think, to SYCL?
I mean, one thing that I always complain about is when SYCL tries to create Uber APIs that are more complex than they need to be. And to give one example, the buffer class, it's hugely complex. It can have hugely different semantics depending on how you construct it, which properties you give it, and so on and so forth. And I think these kinds of things make SYCL difficult to reason about both for users and implementers, and make it also difficult to maintain. I think we should be very careful to not go down further that road.
Yeah, I'll agree with that. And for C++ as well. I mean, as Michael said, we're starting to take into account implementer experience, but we have almost no way to take into account the user experience. And that's really the most important thing of all these. So the doomsday scenario is that we don't get the user experience right and make it usable. And as Scott Myers says, easy to use correctly, hard to use incorrectly.
I can probably point to similar doomsday scenarios for the major languages with SYCL. SYCL is in its early, but it's obviously in its rising stage. I think for any language, there's a legacy cost that builds up over time that stifles the growth ultimately of the language. But that's okay. That's basically the evolution of languages. After a while, the baggage just becomes too much, and then the effort, you finally have to overcome the effort to say, okay, I'm going to bite the bullet and adopt a new language. We don't know, C++ is. We don't know if C++ is at that stage right now. It has a fair bit of baggage. But what's holding it up, I think, is that its willingness to really reinvent itself almost at every release. That could be a good and a bad thing. It's good because as long as the implementation are able to keep up, it's okay. But as soon as implementations are not able to keep up, it's going to be a big problem. And a similar thing will be a problem for SYCL. I mean, you could actually suffer under the weight of your own success. I actually don't worry about CUDA. I worry about them, but I don't think of it as a huge threat, right? In fact, I'm happy to have them there as a mock that I can follow. I can try to take over. And it actually motivates me to have something like that there. But languages have these natural tendencies to eventually groan under their own weight, and dealing with that is going to be something but not yet. I don't think we're at that stage yet. But with success will come a certain amount of price, right? So, not for a while yet. What's going on right now? So I actually tried to put heterogeneity in ISO C++. And I was pretty much rejected. I wasn't rejected. They said, okay, we can't do it because we have millions of lines of legacy code that we have to support. We can't totally revamp the object model, the memory model, so to make C++ heterogeneous. How about we follow what was known as kind of like an experimental approach, where we introduce executors, these execution profiles, as well as the idea of parallel algorithms. They're taking a very incremental step along the way, and each step takes a very long time. And to some of us, it's questionable whether at the end you will actually achieve the kind of heterogeneity and the optimizations that you would want. Now I know kind of NVIDIA is kind of betting on it, right? But they only have to support one processor. So it may be a lot easier for NVIDIA to do it. If you're trying to support a broad range of processors with many different optimization and tuning properties, I'm not entirely convinced that those incremental little tiny steps going along is going to enable that. So my personal view is that no, it will take a long time for them to reach that stage to where they will overtake SYCL.
Yeah, I don't see it as C++ overtaking. It would be nice to have heterogeneity in standard C++, but we're not that young anymore. We'd have to take someone new to, the 20 years to put it in. I mean, C++ doesn't even, it understands threads and multiple cores on a single CPU, but it doesn't even understand like multiple processes or dynamic libraries, right? That's not part of the object model. And it would take a lot to actually put it in, and enough that's general enough to cover a bunch of different processors and not just one vendor. And yeah, I see that. I used to say a 10-year project. I see that as a 20-year project. Yeah. MD-SPAN took 8 years to get into the standard. So, and to me, that's just a tiny little library. And this is a fundamental change to the object model. That's a lot harder.
Actually, two things I want to mention. Yeah, actually, first, I agree with Michael that actually the customer is the key drive for hardware vendors to do something, like to adopt new APIs, like SYCL. I have a question about this. OpenCL 3 has this feature macro to increase the use space and to encourage more vendors to adopt OpenCL. So I'm thinking like, does SYCL have this kind of thing in plan, or should we do something like that to increase the use base and to incentive some like mobile vendors to adopt SYCL? So feature macro basically is just a list of hundreds of features that you can mark one of them and claim you are conformant, OpenCL conformant. But the SYCL right now, I think, it doesn't have this feature. So yeah, just curious.
We talk about feature macro, right? Like the feature test macro, right? So feature test macro is already in C++. In fact, every feature we put in, you're supposed to put in a feature test macro. Whether we want to do that in SYCL, I'm still sort of on the fence on it. I think we need to discuss within the group, which is why I'm interested in what other people think about this. This is where I don't actually I don't dictate. I have to listen with my ears and see what other people think.
I mean, there are already features in SYCL that are optional device features. For example, half support or images. And what that means is that you can use them in your code, but whether it then, so it will compile, but whether it runs, that's then up to the device. I think that's an interesting idea, though obviously at some point it gets very difficult to handle, and usability really suffers if for everything that you want to do, you first need to check if it's supported and then potentially have a fallback. And I think we should really be careful about not taking this too far and maybe even considering some of the features that now are optional, making them mandatory in the sense that the implementation may have to provide an emulated fallback. Because I think it would be much more useful, for example, if half were universally supported, even if ultimately it might have been software emulated if the device doesn't support it natively.
And the feature test macros in C++ aren't to try to fragment the language. They're really, has the vendor caught up and implemented something that we've changed, changing the language of the library. Because that was one of the big fears of adding them to C++, was that it could fragment the language, and we really don't want to do that. And we have these kind of discussions in the Kronos working group. Do we want to add this stuff, and what would be the purpose of it? Because we don't want to fragment that either.
So, Michael, you mentioned something regarding PyTorch, it being kind of a good project to be implemented in SYCL. What are other ideas to bubble these projects up for the community to implement, basically? Looks like it's just stuck on adoption for some of these high-impact, high-value projects that can expose the user requirement towards SYCL.
I'm sorry, I don't quite get all the question. Is it?
Like, what would be the better way of bubbling up project ideas that can expose user adaptation for SYCL?
Okay.
Taking PyTorch as an example.
So the question is, what are some useful projects that a public can do to help enter the SYCL ecosystem. So I mentioned a number of projects already that are still on the docket, and we'd love to have help on it. In my mind, even putting up more information on a Wikipedia page helps. But I'm thinking about things like, you know, enabling our Compiler Explorer support. That is something that is really important in the ecosystem. In my mind, it ties together, because if we have a SYCL reference guide, online searchable, and then we have a SDK, then we can put some of that SDK code as example code in the SYCL reference. And then if we also have Compiler Explorer, now you can actually easily run those example code immediately on different platforms, on different compilers, you know, HipSYCL, DPC++, Compute CPP, as well as some of the experimental ones. And then that just all those projects magically ties together to enable a richer user experience at learning SYCL, at using SYCL, and you know, at finding information about SYCL. It just accelerates the learning so much more. So that's certainly something I want to try to steer the group towards in the future. So software development kits enables you to have a really great initial experience, but they tie together in that I can use that code as example codes in the reference guide, which I'm working on, which we're putting out right now, not the reference guides, but the online SYCL reference page. And then the Compiler Explorer, who knows, right? At the tutorial yesterday, there was a fair bit of time still at getting people running on various laptops and systems. You know, if we have a Compiler Explorer, it would be no time. You just put your code on the web page and you run. So that's my vision. That's why I want to make everything easier in whatever language I'm working on. If I really want to grow, the best thing I can do is try to make everything easier for people. Does that help? Did that answer? I'm not totally sure that answered the question.
The community can see this. Maybe there can be like a list of all the things where people can list some
that could be helpful. Like a page of suggested SYCL projects.
Yeah, just like good idea.
I see what you mean now. Yeah, that's a good idea, I think.